Hi everyone. In this video we will be discussing different examples of differentiation. The idea behind this video is to give you hands-on practice of functions which could possibly come up in solving problems related to differentiation. In the previous two videos we have discussed about sum rule, product rule, division rule and chain rule. So I suggest that you go through that with them if you aren't very familiar with them. If you have done that, then this video is very important for you. In this video we will do some hands-on problems. So we will combine all the different rules and apply them together, and that will be the real test of our knowledge on differentiation rules. Okay, so let us start by solving problems. So the first problem is you have to find derivative of x cube plus sine of tan inverse x by cos square x. Okay, so now this is a good problem to start because this has division. This has cos square x, so it's not a regular function. It has sine of tan inverse x, which is not a regular function. So how do we start? We can clearly see that it's a division problem. So we'll first start by, so this is gx by fx type. So we'll first just directly, so we should learn how to write the answers directly without really trying to do too many steps. So just, this is a denominator, we will take a square of the denominator, that is a division rule. So I hope you are familiar with division rule. So cos square x square, which will be nothing but cos 4x. Okay, then differentiation of the numerator first. So derivative of the numerator. So if I want to take derivative of two functions which are added, then you can just add the derivative separately. So the derivative of x cube is x raised power of n is 3x square, because this is nx raised power of n minus 1 where n is 3. Then sine of tan inverse of x. So we know that whenever you see something like this, you can assume tan inverse x as the argument, and so sin x type problem. So sin x type problem is cos x. So this is cos of tan inverse x, and then you will further differentiate tan inverse x, which is nothing but 1 plus 1 by x square. So that this is the derivative of the numerator. This will be multiplied by cos square x, right, minus, then you will have a derivative of the denominator. So cos square x, again use cos x as the argument here because this is x square type problem. So it will be 2 cos x, like 2x, x square type problem. So 2 cos x, and then the derivative of the cos x, which is nothing but minus sin x, and then multiplied by the numerator, which is x cube plus sine of tan inverse x. Okay, so now you can simplify this, but this is the idea, like this is how you should be able to solve the problems without any difficulties. I mean, this is not a special type of problem, but this is something combining all the type of problems together. Okay, so the next problem is d by dx of sin x sin inverse x into root of 1 minus x square. Okay, so there are three functions, and we have to differentiate these three functions together, so which are multiplied. So one of the ways to do it is to use product rule, because that's the easiest way to think, because there are three functions multiplied. We have learned about the product rule, but there are three functions rather than two functions, so we'll have to apply the product rule twice. So what we will do is, let us initially assume this as the first function and this is the second function. So what does product rule say? Product rule says that you have to differentiate the first function. So derivative of sin x is cos x multiplied by the second function, which in this case is sin inverse x into 1 minus x square. Then you have to multiply the second function, which is plus sin x, multiply the first function and take the derivative of the second function. Now to take the derivative of the second function, you have to again use the product rule. So now in this, let us call this as 2a and 2b. So first derivative of the 2a, which is sin inverse x, so derivative of sin inverse x is root of 1 minus x square multiplied with root of 1 minus x square, plus derivative of the second function 2b, which is 2b in this case, is let us say plus, so 1 minus x square square root. So you will assume 1 minus x square as the argument, and square root x is 1 by 2 root x. This is a formula, standard formula. You should be very familiar with this by right now. So this will be 1 by 2 root of 1 minus x square. and then the derivative of 1 minus x square, which is nothing but 0 minus 2x, so this will be minus 2x. Okay, so this plus can also go away, minus 2x multiplied by the sine inverse x, which is the 2a function. So this 2 can also get cancelled. You can basically simplify this further, but the idea is to show you how you can solve these things in one line. Please practice. I cannot emphasize this more, but like you have to practice this chapter. This chapter is all about practice. The problems may not be very, very tough here, but the idea is that you should be so quick in differentiating functions that you do not face problems in the next chapter, which is the applied differentiation chapter. So I really strongly recommend you to practice these problems a lot and like keep on practicing problems on differentiation. Using product rule, chain rule, sum rule, like just keep on practicing problems like that. So now let me give you one more problem, and then that will be the end of this, and that will be more like a homework problem, so that you can practice that. So the problem is x square sine x plus tan inverse x by e raised power of cos x. Okay, so how will you solve this? So you will first take you will use the similar to division rule. So the denominator will have square, so it will be e raised power of cos x square, which is e raised power of 2 cos x, cos x into e raised power of cos x, which is e raised power of 2 cos x. Okay, it's not cos square x. So just do the square here of the denominator. Then the numerator for x square sin x, you will apply the product rule, and then you will add the derivative of tan inverse x and multiply it with the denominator, and then subtract the differentiation of e raised power of cos x. So you will assume cos x as x, so e raised power of cos x will be e raised power of cos x multiplied by minus sin x, because that is the derivative, and then you will multiply with the numerator. So here I have already given you like what you can expect as the answer, but just do it yourself, and I hope that this video was useful and it allowed you to see how real type of problems will come and how you will apply chain rule, product rule, sum rule together and get the differentiation values. I hope you will check out the next videos, and we'll love to hear your feedback. Thank you.